Pfeiffer with Pfeiffer Hobby Supply, and today I'm going to post this on the how-to page, but today I am going to make a real vain attempt to try and explain to you how I did this reversing loop over here and make the switch throw when the locomotive gets to a certain point. I'm going to do my best. I'm not very good at combining this all together and getting it out there. Maybe I just hope that it makes sense to you once I get done piecing all this stuff together. So stay tuned and I'll try and show you how to do it. Okay, everybody, I've had some questions on how does this loop work. In other words, how does it reverse a train and automatically throw the turnout down here? And today I'm hopefully going to try to explain that to you. And by the way, I've also been asked, why does the loop go out of the room into the garage? Well, the only reason for that was I just thought it would be something cool to do. And number two, the space constraints on a previous layout required me to put a loop out there because I didn't have enough width in the room. So that's the only reason it's there. And normally there's a little window on the outside and you could see the train go through, and it was set up nicely at one time, and it's gonna go back to that whenever I get done here. So let's get started and see if I can explain how I did this. I am by no means an expert. I am by no means able to tell you custom installation jobs or make modifications to this or anything. This was all trial and error on my part. I'm an electrical wizard. I'm not anything else. But I am going to explain to you how mine is wired. Okay, so this is basically kind of a wiring diagram. I'm going to take a picture of this and put a still picture here. You possibly could copy that picture and maybe print it out on your computer or something so you can see exactly how this is wired up when I show you the devices. So let me get a picture of this. Okay, the situation down here is not ideal. I will try and explain it per the diagram and then show you the connections I have on the different devices. The first thing we're going to do is, barring the detection circuits and the automatic switch control, we would start out by normally putting in a reversing unit. And as I said, that up there is a Digitrax AR1, which gave me fits and is no longer functional. So you can just block that right out of your mind. As they say in court, you will disregard that information. This is an MRC reversing module, an AD520. You saw it on the diagram. Pardon me. It has two wires. Well, I'm sorry. It has 4 wires, 2 yellows and 2 reds. It's very simple to hook up. The 2 yellows go to the DCC side or your bus line side. This would go to your bus line, and on my case, it goes up here, ties to a bunch of wires, and those wires go to my bus line. There's a wire that takes off and goes to my bus line. In fact, it's right here. Hang on a minute. That wire is right here. It goes across here, under here, right over here, and then goes over that way and ties into my bus line. And that feeds all this jumble of wires that you see here, and I'm going to explain those one at a time. So this one right here is the feeder wire coming from my bus. One of those feeder wires is then attached to a wire right here, and if we follow this wire down, my 2 yellow wires are attached to those 2 feeder wires, which are in effect tied to my bus line. Those 2 wires go into the reversing unit. The 2 wires come out of the reversing unit and go to another wire, and that wire goes up here, is tied to another wire, which doesn't really mean anything. I mean, it could be the same color, it could be a different color, it doesn't matter. But then that blue-white wire goes up and through the hole in the baseboard, and that wire goes to 2 connectors on my loop. the two connectors on the inside of my loop. Okay? One wire to each rail. It doesn't matter which, it really doesn't matter which one if you're connecting it through a reversing circuit. So the color really doesn't matter, but I try and keep all my of one color on the inside or the outside of the track, but that's neither here nor there. You can see that it comes out of the reversing unit on red, comes right up here, through that splice, through my hand, and up to the layout and ties to the loop. Okay? In effect, those two things, those two wires right there, get you a reversing circuit on your loop. The fact that one side here comes from the bus wire, this side goes to the loop. That gives you a reversing circuit in the loop, barring the automatic turnout control. If you didn't want the automatic turnout control, that would this thing right here would fix you up. Period. Okay? Now let's add in the turnout control. The way we add in the turnout control is, and let me get up here on top of the layout and show you something. Okay, the wire I showed you down below that comes out of the reversing unit is right there, and it goes to two feeder joiners right here, which feed the entirety of the loop. Now, as part of the loop, I have put a set of insulating joiners here, and a set of insulating joiners here. That makes this an individual piece, a section of track in itself, okay? Done the same thing here. Two insulators here, two insulators right there, okay? That, in effect, makes this its own section of track. So now we have a loop that's controlled by the reverser, and we have a track here that has the same polarity as the layout. We have another curved track here that has the same polarity as the layout. However, the only difference is, because these are segregated, they are being fed through this wire here and another wire. I think it's over in here somewhere, right here somewhere. Anyways, and those feeders go through what is called a BD20, and now I'll take you back down and show you that. By the way, as long as we're up here, the turnout is being fed, as I always talk about, from the layout side, okay? So the power's coming in here, feeds the turnout, then we have insulators on the outgoing side of the turnout. Then we have a detection section, and a detection section, and a loop. That's the components of this. Now let me go down and show you where those the wires to these detection sections go. And by the way, I'm going to reiterate, I'm not a college professor. I don't know anything about electronics. This is all just through trial and error. So don't bombard me with a bunch of questions on how do I do it this way, how do I do it that way, because I won't be able to answer them. Okay, so I have basically two detection. Well, let me rephrase this. What I have is two feeder wires multipled on to the feeder wire that I told you comes from the layout right here, okay? It goes to this, and all these wires are multipled off of that in their appropriate colors. On these BD20s, and I believe these are NCE. Yeah, they are NCE. It's upside down, but I believe you can see NCE BD20. They're nothing more than a detector, okay? So the line going to each one of those sections is being fed from basically from the layout, okay? And they go up and one side, and it doesn't matter which side, but only one side goes through the detector coil. And I chose to run them through there a couple of times to try and ensure that they detect motion or current passing through this wire when a locomotive enters that section. Then you can see that goes down here, is spliced to a feeder wire, and that feeder wire goes up to detection circuit number 2, which I don't know which one that is, but it doesn't really matter. It's just that I got to make sure 2 here is to 2 here. Okay? Now, I have a duplicate of that and another BD20 here, which is detection circuit 1. And it is marked D1 here. And that would go to the other detection section. So now we have one of these NCE BD20s wired into, through the coil, not wired really into, but the feeder to those sections through the coil on the detector. The job of that wire being fed through the coil is to detect the current when it passes through this. At that point, then this detector sends out a signal. That signal then goes up here and attaches to, and this is going to be crazy, but let me see if I can get the camera up here. Okay, I don't know what the directions say, but this is what worked for me. You can see that I have one side of the turnout control attached to this pin on the switch cat. This is a switch cat, an NCE switch cat. Switch cat stands for switch Kato. Okay, it's a polarity reversing switch controller. So one side of this is detection circuit 2. It could be 1, it doesn't matter. Goes up here. You can see that the violet wire is attached to this lug. So if you're looking at the switch cat lettering up here, and let me try and get it. You can see that that violet is attached here. Now the other side is attached to a ground in the middle. And the other white is attached to that same ground in the middle. Then I have a violet wire attached to the next one up on the switch cat. What this does is this is the polarity reversing. This is one polarity, these two are one polarity, these two are the other polarity. Okay? Or not the polarity. These are the current, these bring the current into the switch cat, and either these two terminals or these two terminals tell the switch cat to switch. Okay? Now, on this side over here, I have power, once again, layout power, multiplied through this bundle of wires right here. Another set of wires going up and feeding into the top 2 lugs of the switch cat when it's oriented in this manner. Then these 2 lugs on the bottom here go out to the switch machine via, and you can see this says something, switch cat number 3 turnout, okay? This is spliced together here, and it goes up and goes to the turnout that we're trying to control. So let me see if I can summarize this. You have 2 detectors. Each detector can control one side or the other of the switch cat. The switch cat then makes a decision to send current to the switch machine, a burst of current to the switch machine. The switch cat is powered by the track power that is connected here. When it creates a burst of power here, that goes into this wire here, which goes to the turnout and either throws negative here or positive there, or negative here and positive there, depending on which detector it hits. These wires can be turned over to determine which one throws which direction. In other words, whether positive is here and negative is here, or vice versa. That determines which way the switch is thrown when it hits either one of these 2 blocks. I hope that makes sense, because that's about all I can explain to you about how I know this works. But you can see that the detector really doesn't need anything to send out a signal. There's no power going into this detector. Only the current that it gets through it running through this coil here allows it to make a switch and send a pulse out on this wire right here to the switch cat. And the same thing with the opposite one. Sends a signal when it gets to that one and sends a signal up to the switch cat. Then the switch cat sends out a signal to the turnout and throws the turnout. I hope that makes sense, because that's about as well as I can explain it. Now, the other two turnouts that you saw up there are not automatic. They go through the DS64 right there, one on switch position that I've numbered 21 and one on 22. The one on the far left is 21, the one on the right is 22. And when I program these 64s, I generally write the numbers on there so I can remember what I programmed them at. If not, you have to go back and set them to their default setting, then go back in and reset the numbers on the DS64s. But this DS64 is a whole separate thing from what we're looking at here, okay? So if you compare that to the pictures, and I'm going to take some still pictures of the Switch Cat and the BD20's, and you can study that wiring, and hopefully it makes sense to you. So I'm going to go ahead and make the still pictures, and we're going to wrap this up. I'm putting this ahead of the end, but it's just a little afterthought I had after I finished doing my sign-off. And that is, if you have trouble figuring this out, maybe my diagram isn't 100% correct the way the components are, but if you just study the components and where I show one component and I take you to where it goes on the next component, and if you look at the pins or the screws on those components, you will be able to, it will come to you, I hope, where they go on the components and how those components work in conjunction with each other, and it will make sense to you, I hope. So, thanks for watching. Okay, everybody, I hope that gobbledygook came together for you in some way. I can visualize it in my head, but maybe I don't explain it well enough for people to visualize it in their head or get how it comes together. But I hope between the diagram that I made up there and seeing the actual components makes some kind of sense to you and helps you out in some way to try and hook one of these up. It's really not as difficult as even my mind tries to make it to me. Once you get it going, it seems like, ding, why didn't I think of this? But at least for me. But that's it for today. Hope you enjoyed it, and what do I always say? Thanks for watching.